What are earthquakes? Hopefully, at this point in time in your life, you know what an earthquake is. But the actual definition is the shaking or trembling caused by the sudden release of energy. Now, that release of energy is caused by the plates moving along a fault boundary. Okay, a fault or a plate boundary. And aftershocks are actually the continuing adjustment of those faults. So think about the transform plate we were talking about. Think about them sliding past each other. They're not smooth, they're rough, they're jagged, and they bind up. So they bind, pressure increases, and they snap. That snap causes the earthquake. So right here, that's what I'm talking about. You've got this fault line where the two plates are moving past each other. They don't move smoothly. Okay, they bind up, they snap, then they bind up again. A fault is not a straight line like this. Picture jagged rocks all on both sides. Where that snap takes place is what we call the focus. That's where the earthquake occurred. The point above the focus on Earth's surface is called the epicenter. Focus underground, epicenter on the surface, directly above the focus. This is what we call a seismograph. Seismograph is this whole instrument right here, and right here, where you see that little needle moving, that would be the seismogram. That will show you the waves when they arrive at a seismograph station. It records the earthquake. All right. At convergent boundaries, focal depth increases. So as this plate goes down, the focus is going to get deeper. See it? Surface down as the focus goes down. Excuse me, as the plate goes down, the focus will be deeper. All right. Now we're going to talk about the P and the S wave. Now these are very, very important. And the reason for that is these waves and their difference in speed will help us to find where the epicenter took place. Getting a little ahead of myself though. So P is a primary wave. It's the fastest wave, and it goes through solid, liquid, and gas. All right. S wave is slower than a P wave, and it can only travel through solids. So P is the fastest, S is slower. Now, because these two waves move at different speeds, we are able to figure out a lot of different things from that. And that's what we're going to be doing as I continue. And then we talk about the R and the L wave. These are actually the waves that cause the damage, the surface waves. Okay. The P and the S wave don't cause damage, the surface wave does. Size and strength of the earthquake are measured. Intensity, subjective measure of kind of damage done, and the people's reactions to it. That is what we call the Mercalli scale. So the Mercalli scale, let me go to the next slide. Let's go back. So the Mercalli scale is based upon man-made items. Mercalli scale talks about objects falling off the wall, houses falling off their foundations, and these are all different levels of the Mercalli scale. We don't go into too much depth on that. If there's an earthquake in the middle of a desert where nobody lives, you're not using the Mercalli scale because it doesn't work for anything. The scale that most people know of and have heard of is what we call the Richter scale. Okay, 7.5 on the Richter scale, 5.2 on the Richter scale. Richter scale measures the total amount of energy released by the earthquake, independent of intensity. Intensity is Mercalli scale. Richter scale is just the strength of it, the magnitude of it, the power of the earthquake.